In this video, we're going to interpret graphs of linear equations, quadratic equations, and inequalities. As you're interpreting these graphs, one thing you can look at is the steepness of the line. Does it have a large slope or does it have a smaller slope? We can also look for changes and trends. Sometimes you have a line that increases at a certain rate and then has a zero slope and then starts increasing again. We can look and see where a line is increasing, that's when it has a positive slope, or decreasing. And then we can determine solutions by looking at the graph. Let's look at the following graph. If you notice, the y-axis measures distance in kilometers, and the x-axis measures time in hours. What we have here is two trains, train A and train B. One way that we can interpret what's going on with train A and train B is by looking at the slope of each of the trains. Remember that the slope is the steepness of the train, or the change in y over the change in x. Let's first look at the slope of train A. To find the slope, you need 2 points on the line. 0, 0 is 1 point on train A's line. Now 35, 1 is not exactly on the line, but it's close enough to interpret the slope. What that means is that at 1 hour, train A has gone 35 kilometers. Now let's look at train B. We can use 0, 0 for train B as well. Then if you look, in 2 hours, it's gone about 35 kilometers. So train B has gone about 35 kilometers in 2 hours. Now to compare these, it's going to make it a lot easier if we can get it in 1 hour just like train A. So we can divide both of these by 2. So train B is going about 17.5 kilometers per hour. By looking at the slopes, you can see that train A is moving faster than train B. Now, let's look at another type of graph. This is a graph of a parabola. Unlike the last graph, a parabola does not have a constant rate of change, meaning the slope or the steepness of the line changes throughout the graph. In this graph, the y-axis is measuring the height of an object in meters, and the x-axis measures the time in seconds. At first, the object is increasing in height as time passes, but after a certain point, it hits the highest point of the graph and the line starts decreasing. Most likely, an object is thrown into the air and gravity is going to make it eventually come back down to the ground. One thing that we can look at is at what time the object changes directions. Well, you can see that happens at about 5 seconds. We can also look and see at what height does it change directions. In this case, we can approximate and say about 118 meters. We can even look at the slope at different points in our graph. For example, what is the slope between 0 seconds and 1 second? Slope is the change in y over the change in x. So between 0 seconds and 1 second, our change in y is 40 meters, and our change in x is 1 second. So it changes at a rate of 40 meters per second at that point in the graph. What about the slope between 2 seconds and 3 seconds? When you look at the change in y, from 2 seconds to 3 seconds goes from about 75 to 100. The difference is about 25 meters. And the change in time between 2 seconds and 3 seconds is 1 second. So between 2 seconds and 3 seconds, our slope changes about 25 meters per second. Which one is changing at a faster rate? If you thought between 0 seconds and 1 second, you're right, because 40 meters per second is a bigger slope than 25 meters per second. Let's look at one more type of graph. This graph shows the solutions that solve the inequality y is less than or equal to 2x minus 3. Everything in the shaded region makes it true, so let's try one. 3, 0 is in the shaded region. If you plug those points into this inequality and solve, it should be true. The 3 is your x value and the 0 is your y value. So plug the numbers in and solve. 2 times 3 is 6, and then 6 minus 3 is 3. Is 0 less than or equal to 3? It is. So you can clearly see that that's a solution. Now we can try one that is not in the shaded region to prove that it's not a solution. Let's try 1, 1. The x value is 1, and the y value is 1. So again, plug the numbers in and solve. 2 times 1 is 2, and 2 minus 3 is negative 1. Is 1 less than or equal to negative 1? No, so it is not a solution. We could also look at the line of the graph. Notice that it is a solid line. This is because the inequality has that equal to sign in it. That means that everything on the line is also a solution. If it did not have the equal to sign, such as less than or greater than, then the line would be dashed, and anything that would be on the dashed line would not be a solution.